Alright, in this video we're going to look at finding the difference quotient of a function. And the difference quotient is, for those of you going on to calculus in your future, it's fundamental to the idea of what's known as a derivative in that course. So for a given function, f of x, the difference quotient of that function is f of x plus h minus f of x, so we're subtracting functions here, all divided by h. And it looks a bit intimidating at first, but really it's just three different components to it. So first up is this f of x plus h part in the upper left. That's what we're going to do first. We're going to evaluate the function at x plus h. Then we're going to subtract the original function from that result. So that after step 2, we would have taken care of the entire numerator in this expression. And then step 3, we're going to take that result that we got from subtracting them, we're going to take that difference and divide that result by h, and that'll take care of our difference quotient. And then in calculus, you just take this answer and go one more step. So example 3, we're going to find and simplify the difference quotient for each of the following. So let's start with f of x is x squared minus x minus 2. First step, we're going to evaluate this at x plus h. So we'll plug in x plus h in wherever we see an x. So x plus h in parentheses squared, and then minus the x plus h here, and minus 2. X plus h squared is x squared plus 2hx plus h squared. And you'll probably see quite a few quadratic expressions, so it might benefit you in terms of time to know that x plus h in parentheses squared is x squared plus 2hx plus h squared. Then distribute the negative to the x and the negative to the h. We get minus x minus h, and bring down the minus 2. Second step is we're going to subtract this original function from this result. We don't have any like terms to combine with the result from f of x plus h, so we'll take that f of x plus h result and then subtract the original function. And because we have more than one term in the original function, we have to use parentheses and distribute the negative to each of those three terms. So when we do that, we get the f of x plus h result minus x squared plus x plus 2. And what we'll notice here is the minus x squared is going to cancel out this x squared, the plus x is going to cancel out this minus x, and the plus 2 is going to cancel out this minus 2. So we'll get rid of some terms, and all that'll be left after we cancel out the x squared, cancel out the x's, and then cancel out the 2's is 2hx plus h squared minus h. So 2hx, h squared, and minus h. So that's step 2. And then step 3, we're going to take that result and divide it by h. So we're going to take each term and divide it by h. So 2hx divided by h is 2x. H squared divided by h is h, and then negative h divided by h is minus 1. So our difference quotient is 2x plus h minus 1. So it's really just three smaller steps put together. All right, part B, g of x is 3 over 2x plus 1. So we're going to start by evaluating g of x plus h. 3 over 2 times the expression x plus h plus 1. A little bit easier to do this one because we just have to distribute the 2. And we get 3 over 2x plus 2h plus 1. All right, step 2, we're going to subtract our original function, so minus 3 over 2x plus 1. And then divide everything by h. So rather than try to figure out what this simplifies to for g of x plus h minus g of x, we can just divide everything by h. And notice we have a complex fraction here. So we have a tiny denominator of 2x plus 2h plus 1 and another tiny denominator of 2x plus 1. So we can multiply every single term in this complex fraction by our least common tiny denominator, which in this case is going to be the 2x plus 2h plus 1 times the 2x plus 1. So it looks intimidating, but we're really at this step just going to clear out these tiny fractions here by multiplying every single term by the product of the denominators. So you can always get a common denominator by multiplying them. All right, so 3 over 2x plus 2h plus 1, when we multiply that by 2x plus 2h plus 1 times 2x plus 1, we get the 2x plus 2h plus 1. They're going to cancel out, leaving us with just 3 times 2x plus 1. And then minus 3 the 2x plus 1's cancel out, so minus 3 times the 2x plus 2h plus 1. And then we don't have to multiply everything out necessarily down here. We just leave it as h times the 2x plus 2h plus 1 times the 2x plus 1. All right, distributing the 3 and the negative 3 in the numerator, we get 6x plus 3 minus 6x minus 6h minus 3. Up top, we got some like terms that cancel out, leaving only the negative 6h. The 6x minus 6x is gone. The 3 minus 3 is gone. So we have negative 6h over h times this expression. The h out in front here is going to cancel out this h after the 6, leaving us with negative 6 over 2x plus 2h plus 1 times 2x plus 1. So really it's just an exercise in simplifying complex fractions by multiplying everything by the least common tiny denominator. All right, example 3, part C here is be our final example. We have r of x is the square root of x. So first let's evaluate the r of x plus h is just going to be the square root of x plus h. That's pretty simple. Subtracting the original function, we get the square root of x plus h minus the square root of x. So not bad. Then we're going to divide that by h. And in terms of what we have here, to go any further, we can actually multiply the numerator and denominator by the conjugate of the square root of x plus h minus the square root of x. Now, the conjugate of this expression just changes the minus that separates them to a plus. So when we do that, what will happen is we'll be able to eliminate our radicals in the numerator. And when we multiply through square root of x plus h times the square root of x plus h gives us a square root of x plus h, that whole thing squared. This positive square root of x times the square root of x plus h and this negative square root of x times square root of x plus h, they end up canceling each other out. And then what we're left with is negative square root of x times positive square root of x is negative square root of x squared all over h times this expression. Now in our numerator, square root of x plus h squared is x plus h, and square root of x squared is x. We have x plus h minus x over h times the square root of x plus h plus the square root of x. And combining like terms in the numerator, the x's cancel out. We have h over this denominator, and then the h's will cancel out, leaving us with 1 over the square root of x plus h plus the square root of x as our final answer. All right, that about does it for this video. Thanks for watching. I'll see you next time.